Good morning, students. Today we are starting another important topic, that is electronic devices. First of all, what is this electronic devices? A device whose action is based upon controlled flow of electrons through it. Obviously, when electrons are flowing through the device, that is taken as electronic device. So a device whose action is based upon, किस पर based है? Controlled flow of electrons through it. Now, the branch of physics which deals with these electronic devices, that is termed as electronics. So where you study electronic devices. Basically, we will just introduce, I am giving you the general concept of these electronics, earlier the electronic components or devices as well as new ones. First of all, if we discuss the older one, that is at the initial time, this vacuum tubes were there, and later on solid state electronic devices came into existence with the development of technologies. This vacuum tubes that can be of two types, that is vacuum diodes. It has two electrodes like you can say like positive electrode, negative electrode. इसमें basically two terminals होते थे vacuum diodes. Another that will be pentate, जिसमें 5 electrodes होते हैं, but its life is limited and low reliability. Whereas solid state electronic devices, in 1930 these devices were realized. Now it is of I am categorizing it as junction diode. Junction diode यानी 2 electrodes. Another can be transistors, although transistor we will not study here, but I will just introduce to you. This is you can say transistor with having 3 electrodes, 3 terminals, and their life as compared to it is long life and highly reliable. So nowadays here these are the basic components on the basis of different diodes, different electronic devices are developed. Now, as here if we study solids, classification of solids, there are basically 3 categories. Metals having low resistivity, but conductivity is high. You can see how it is having more conductivity, because valence electrons are available. With a small amount of energy given to it, then it can conduct. So due to its higher, you can say that electrons can easily be available by giving small energy, so its conductivity is high. Insulators, its conductivity is low, or you can say it has negligible conductivity, but resistivity is high. Obviously, if it is not conducting, then restriction, then opposition to the flow of electrons, that will be more, and hence resistivity will be high. So with the small energy, electrons cannot be made free from the orbits. यानी इसको बहुत ज़्यादा एनर्जी चाहिए एक इंसुलेटर मटेरियल से इलेक्ट्रॉन्स को लिबरेट कराने के लिए. So that's why they are not conducting electricity. They are poor conductor of electricity. In between these two, there is another material, that is semiconductor. Here we will study in detail semiconductor within this electronic devices. It has intermediate conductivity as well as resistivity, both. That is having its conductivity and resistivity lie in between metals and insulators. So now semiconductors that we have to study in detail. Basic elementary semiconductors that can be silicon, germanium. Apart from it, some compound semiconductor materials are there. Further, this can be categorized as inorganic and organic. Inorganic examples can be like this: gallium arsenide, cadmium, indium phosphide, etc. Many examples can be there. We are not going to discuss it in detail, just I am giving you an example. Whereas organic semiconductors, that is compound के जो example ले रहे हैं, that can be polymers, so these can be polymers, polyaniline and polypyrrole, etc. So these are the terms which you can have, maybe you have studied in chemistry also. Our purpose is not to discuss this in as an example form. We will study basic here, elementary semiconductors and the concepts related to it. Now this classification of semiconductors, basic, it is of intrinsic type semiconductor. Intrinsic यानी कह सकते हो pure semiconductor, that is free from any kind of impurities. और अगर कंडक्टिविटी की बात करें, इसमें नंबर ऑफ इलेक्ट्रॉन्स एंड होल्स इक्वल होते हैं, ऑल्दो आई विल डिस्कस इट इन डिटेल. Another type of semiconductor is extrinsic semiconductor. Extrinsic semiconductors यानी ये जो semiconductor होते हैं, these are not pure semiconductor, but this can be obtained by some doping. Doping means addition of some impurities to pure semiconductor. यानी intrinsic semiconductor में हम doping करते हैं, यानी कुछ हम element add करते हैं to the pure semiconductor, and hence we can get this extrinsic semiconductor. Now we have to study energy level diagram, energy band diagram. So when we are dealing this energy band, this is not level, energy band diagram. इसमें आपको एक चीज़ समझनी है कि सबसे पहले चाहे आप metals या insulators या semiconductor की बात करेंगे, तो इस energy band diagram को 3 parts में divide किया गया है. First, this is the valence band. This is valence band. Topmost is conduction band. Just overview we are taking, we are not going in much detail of this energy band diagram. And valence band and conduction band, this is separated by this gap. This gap is taken as energy band gap. Just this is the depiction कि how we can represent this energy band diagrams. इसमें सबसे पे lower level पे valence band, फिर conduction band और बीच में ये energy band gap होता है. अब इसको हम explain करते हैं. What is this valence band? This valence band, basically now you can just easily judge it that this is the lowest band, right? This is the lowest energy band. And अभी किससे बना होता है? It is filled with, as valence word है, valence means valence electron से. So it is the lowest band filled with valence electron. So this is the valence band, just a basic concept I am giving. Then conduction band. Conduction band क्या हुआ? Here you can say, so now this conduction band, as you can see from here, it is the upper band of this energy band diagram, and you can see that here initially electrons are present in the valence band, but at 0 Kelvin, initially at initial level, no electron is available for the conduction. So you can say this band is either empty or partially filled with इलेक्ट्रॉन, यानी इलेक्ट्रॉन को वैलेंस बैंड से कंडक्शन बैंड में जाने के लिए कुछ एनर्जी प्रोवाइड करनी पड़ेगी. सो इलेक्ट्रॉन विल रिक्वायर सम एनर्जी टू जंप टू कंडक्शन बैंड. सो हाउ कैन यू डिफाइन इट? दिस इज द अपर बैंड in which electrons are not present, especially initially at 0 Kelvin. So at room temperature, band is either empty और partially filled. ये डिपेंड करता है अलग अलग मटेरियल को जो हम यूज़ कर रहे हैं. Now, as we have shown here, valence band and conduction band are not close together. These are separated by certain this gap. This is energy band gap. This is energy gap, you can say. So this you can say that valence band and conduction band are separated by a band that is energy band gap. तो मिनिमम एनर्जी, अब इसको हम बैंड गैप के कोरस्पॉन्डिंग कुछ एनर्जी देनी पड़ती है, तो उसको हम रिप्रेजेंट कैसे करते हैं, दैट मिनिमम एनर्जी रिक्वायर्ड फॉर शिफ्टिंग इलेक्ट्रॉन्स फ्रॉम वैलेंस बैंड to conduction band is termed as energy band gap. So I am representing it by EG. G for gap. This is energy band gap. यानी इसके corresponding आप कह सकते हैं कि this is a gap between valence and conduction band, और actually इसकी corresponding जो energy है वो क्या है, minimum energy required for shifting or for moving the electron from valence band to conduction band. अब अगर हम इसको expression form में लिखना चाहें, this will be h into nu or h c by lambda, where h is Planck's constant, c is velocity of light. And energy band gap for different material is different. And this is also called forbidden energy gap. Now Fermi level, just we will learn the definition. It is the highest energy level in conduction band filled with electron at absolute zero. So this is the Fermi level. And energy corresponding to this level is known as Fermi energy. Now here we will discuss the differentiation between conductors, insulators and semiconductors on the basis of band diagram. First of all, we will draw this band diagram for metals. As if we take metals, we are taking, this is the conduction band, this is band gap energy, or you can say forbidden gap, and this is the valence band. So in case of metals, here you can see that conduction band is either partially filled with electron, that means it is partially filled with electron. Which band? Conduction band in metals. Or conduction band and valence band partially overlap each other, means there is no forbidden gap energy, there is no band gap energy. So here if we have to draw such condition, in that condition you can say that this is the conduction band and this is the valence band, and there is an overlapping. So due to overlapping, like this is a condition where this small part of conduction band, this is merged with valence band, and hence this part is overlapping and there is no band gap energy. Now after this, next band gap is of insulator. In case of insulator, when we draw band diagram, here you will see that valence band is completely filled with electrons and conduction band is empty. Where this band gap energy, this is a main point, this value is greater than 3 electron volt, especially for the case of insulators. There is a large band gap energy between this. So one example of insulator is diamond. Diamond has a band gap energy of 6 electron volt. So it means electron, when it will gain very large amount of energy, only then it will be free to come for conduction in conduction band. So that's why it is having, you can say that valence band and conduction band are large, separated by large amount, large distance, so that much energy is required. which is electrically not possible. Now, semiconductors. If we draw the band diagram of semiconductors, you will see here this again valence band and conduction band is there. Here valence band is completely filled with electron and conduction band is empty. But the main difference between these two is that this energy band gap, this is less than, this energy is small and this is less than 3 electron volt. For insulator, its value is greater than 3 electron volt, and for semiconductor, its value is less than 3 electron volt. Especially if we take germanium. For germanium, this band gap energy is equal to 0.72 electron volt. And for silicon, this band gap energy is 1.1 electron volt. At absolute zero, at 0 Kelvin, what will happen? As electrons are not able to cross even the very small energy gap. So conduction band remain empty, especially at 0 Kelvin. So semiconductor at 0 Kelvin, this semiconductor behave like insulator, but only under this temperature. Even at room temperature, some electrons from this valence band acquire some thermal energy, which energy is greater than 3 electron volt, which energy greater than band gap energy, that is 3 electron volt, and hence it will cross it. So basically electrons become available for conduction. So this is a basic idea of metals, insulators and semiconductors in terms of band diagrams. Now we have to study in detail different types of semiconductor, as I have introduced the concept of intrinsic and extrinsic semiconductor. Intrinsic semiconductor, as I have introduced this concept, this is a pure semiconductor, that is, which is free from any kind of impurities. And electrical conductivity of these semiconductor is possible by the number of electrons excited from valence band to conduction band. An electron get excited from valence band to conduction band, and this is constituting conductivity. This is also called intrinsic conductivity. Now, if we take germanium and silicon, as we know germanium, it has an atomic number 32. So electronic configuration for this germanium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. It means you can see here the 4 electrons are treated as valence electron. Whereas for silicon, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. Again you can see here 4 valence electrons. So both the atoms have 4 valence electron. So the crystal structure of this germanium or silicon, if we will draw, you can see that for each of this germanium there are 4 valence electron. So what will happen? That these germanium will share these electrons. So the 4 valence electrons of germanium atom form 4 covalent bonds. Each of this element, each of this atom will form covalent bond by sharing the electron of neighboring 4 germanium atom. So each covalent bond share 2 electrons, one from each atom, you can see. So basically in this case you can say that the outermost orbit of each atom is complete, that is with 8 electrons, having no free electron. अब यहाँ पे आप देख सकते हो इसके पास 4 वैलेंस इलेक्ट्रॉन है. तो अगर यहाँ पर ये हर जगह, क्योंकि हमने एक स्मॉल पोर्शन दिखाया है, तो हर एटम एक एक्स्ट्रा इलेक्ट्रॉन कोवेलेंट बॉन्ड से शेयर कर रहा है टू कंप्लीट 8 इलेक्ट्रॉन्स. सो इट मीन्स here there will be covalent bond will be there. Now as temperature increases, that means you can see at room temperature, you can see here. So at room temperature, basically now this electron will gain energy. So at absolute zero, all the 8 electrons are completely full by covalent bond, and hence now as the temperature increases, what will happen? Electron from the valence band gain energy and it will become free for conduction. So you can say it will move in the conduction band. So if I will draw its energy band diagram, you can see here this is the valence band, this is the conduction band, and if we specifically taking it for the germanium, so for this band gap energy is 0.72 electron volt. So electron present here, these are completely filled, they will attain energy greater than this 0.72 electron volt and hence move to the conduction band, and it will become available for conduction in the conduction band. So here as you can see the same number of holes will be generated. अब होगा क्या यहाँ से, जब एक इलेक्ट्रॉन वैलेंस बैंड से कंडक्शन बैंड में चला गया तो बेसिकली जितने इलेक्ट्रॉन्स मूवमेंट होंगे उतने ही होल्स जनरेट हो जाएंगे. So you can say number of holes equal to number of electrons. So conduction current is due to electronic current and hole current. Now what is the hole? If we have to define this hole, this is nothing but this is the absence of electron in valence band. So it is basically the absence, यानी एक इलेक्ट्रॉन की मूव करने से यहाँ पर जो वैकेंसी क्रिएट हो गई, that is treated as a hole. So if we have to draw this energy band diagram at 0 Kelvin and you can say at room temperature. So what you have to show this is a valence band and conduction band is quite empty at T equal to 0 Kelvin. Whereas when temperature is greater than this or at room temperature, when the electrons gain energy, sufficient energy to cross this band gap energy, so in that particular case, now you have to show that few electrons are available here for the conduction and their vacancy is left. This is T greater than 0 Kelvin. This energy is gained by the electron by getting sufficient energy. So leaving behind the vacancy, that is hole. Now, here to get extrinsic semiconductor, we require some impurity to be added. So what is doping? Doping is the process of deliberate addition of desirable impurities to a pure semiconductor to increase its conductivity. Basically, doping is done to increase the conductivity. Now, what are the essential characteristics of dopant? As this concentration of dopant should be small. It should not be large. Second, it should not disturb the crystal structure. It should not disturb lattice crystal structure. And its size should be almost same as that of the atom which are used in the crystal structure. Last point, semiconductor material that we are using should be of high purity. That means doping जिस material में कर रहे हैं, that should be of pure. Semiconductor material is pure. So these are the essential characteristics about the dopant when we are adding some impurities. Now by doping we are getting another type. This is extrinsic semiconductor. So how we are getting extrinsic semiconductor? By addition of some impurities to pure semiconductor, that is intrinsic semiconductor, we are getting extrinsic semiconductor. So extrinsic semiconductor, a doped semiconductor, that is, you can say, or a semiconductor with impurity atom, suitable impurity atom added to it. This is called extrinsic semiconductor. This extrinsic semiconductor is categorized into two types, that is N-type semiconductor and P-type semiconductor. First of all, we will discuss N-type semiconductor. Now, N-type semiconductor, this can be obtained from a pure semiconductor, like you can take germanium or silicon, in which we are adding the impurities with the, that is, you can take when pentavalent impurity is added. That means atom with 5 valence electron. So N-type semiconductors can be obtained by adding pentavalent impurities, pentavalent atoms. Example of such particular atoms can be arsenic, phosphorus, or antimony, or bismuth. Many more examples can be there. We are taking few which has 5 valence electrons. So now, if I will just draw the crystal structure, I am taking again germanium. You can take silicon also. As you can see here, there each of the atom of germanium has 4 valence electrons, so forming covalent bond with the neighboring one. अब यहाँ पर हम किससे replace कर रहे हैं? We are replacing this germanium atom with the phosphorus, or any of these example. Let I am replacing it by phosphorus. So what will happen? That phosphorus have 5 valence electron. So in that case, 4 of the valence electron of phosphorus will form 4 covalent bond with the neighboring germanium atom, and the 5th electron, this will remain attached to this atom. It will not get separated initially. Initially, at the instant, their 4 electron will form covalent bond with the neighboring germanium atom, and the 5th electron will remain as attached with it unless and until it will get sufficient energy. This 5th electron, this is loosely bound with the parent impurity atom and it is comparatively free to move. यानी इस इलेक्ट्रॉन को कंडक्शन के लिए थोड़ी सी एनर्जी चाहिए, बहुत ज़्यादा नहीं चाहिए. Then as it is easily available for conduction by gaining sufficient energy, and that binding energy for electron is 0.045 electron volt. This is the binding energy for this extra electron. This is for silicon, and if we are taking germanium, this value is 0.01 electron volt. So now here basically this particular impurity atom which we are adding, this is taken as donor atom. That's why N-type semiconductor is also termed as donor type, because here this impurity atom is donating one extra electron for conduction. So that's why it is donor type or N-type. So now on giving up this 5th electron, donor atom will become positively charged. जैसे ही एक इलेक्ट्रॉन इससे डिटैच हो जाएगा, बाहर निकल जाएगा, तो क्या होगा? लॉस ऑफ इलेक्ट्रॉन के बाद इट विल गेट आयनाइज्ड और इस पर कैसा चार्ज हो जाएगा? पॉजिटिवली चार्ज. Although matter as a whole will remain to be neutral. This you have to understand, that complete matter, this will be remaining as a whole, as a neutral. Now if I have to represent this in terms of energy band diagram, so this band diagram which I am drawing here, you can see that this is the valence band. Here electrons are present. Now this is the conduction band. initially it is empty. Now the phosphorus atom which we have taken, that is impurity atom, corresponding to that, that extra electron will remain in this level. This is the donor level. In n-type semiconductor, as you know, you have to just learn the point कि ये डोनेट करता है, तो इलेक्ट्रॉन वैलेंस बैंड में नहीं होगा क्योंकि वो लूजली बाउंड है उस एटम से, तो वो इलेक्ट्रॉन कहाँ रहेंगे, इस डोनर लेवल में. तो अब अगर इसको एनर्जी मिल जाती है 0.01 इलेक्ट्रॉन वोल्ट, क्योंकि हमने जर्मेनियम का केस लिया है, देन इट विल बी इजीली अवेलेबल फॉर कंडक्शन फ्रॉम डोनर लेवल टू कंडक्शन बैंड. एंड रेस्ट ऑफ द इलेक्ट्रॉन्स from the valence band become free by breaking of covalent bond. So at room temperature, what will happen, this covalent bond break, and you can say there will be number of holes will be produced because electron will be moved. So here conductivity in this case, you can say in case of n-type semiconductor, this is due to the movement of electrons. Here number of electron is greater than number of holes. क्यों? क्योंकि यहाँ पर already इस केस में हमारे पास जो n-type semiconductor है इलेक्ट्रॉन अवेलेबल है. यानी जब डोपिंग की जाती है तो बहुत स्मॉल अमाउंट में की जाती है, तो अगर हमारे पास 1% भी हम डोपिंग ऐड करते हैं तो उतने ही नंबर ऑफ इलेक्ट्रॉन्स कंडक्शन के लिए अवेलेबल हो जाते हैं. सो कंडक्टिविटी in n-type semiconductor is majority due to the number of electrons, although number of holes are generated, but it will be less as compared to number of electrons. So majority charge carriers are here electrons and minority charge carriers are holes. So this is about n-type semiconductor. We have just given a brief review about brief concept because already you are familiar with this concept in chemistry. Now p-type semiconductor. P-type semiconductor, as P stand for positive, and this is also known as acceptor type. How can we produce this p-type semiconductor? This can be produced by adding impurities from third group. That means you can say we have to add the atom which is having 3 valence electrons. So trivalent impurity must be added to pure semiconductor to get p-type semiconductor. What can be the possible example? Examples of it can be boron, aluminium, indium, etc. So now if I have to draw its crystal structure, you can see here I have just explained all the concept for taking germanium. Here germanium, I will replace one of the germanium with the, you can say either indium, boron. Let I am replacing it by boron. So now you can say here each of the germanium atom is having 4 valence electron, but boron has 3 valence electron. Now you can see here this electron of boron will form covalent bond. This electron will also form covalent bond. This is also forming covalent bond, but here there is a vacancy. There is no electron available for conduction. So 3 electrons of this boron or aluminium, whatever dopant I am using, is shared 3 electrons with the germanium atom, but 1 electron is missing. So here what will happen, that to form this covalent bond neighboring this germanium bonds may break. यानी actually at 0 Kelvin it will be remaining as such, लेकिन room temperature पे क्या होगा कि ये neighboring germanium bond, any of the crystal structure bond may break up and it will move to compensate this deficiency of electron, maybe from this, maybe from this, from anywhere. That electron will move to complete the vacancy of electron. So now here these trivalent atoms, these are called acceptor atom, and conduction of electron occur due to movement of the holes. So because here initially is a hole, जैसे ही कोवेलेंट बॉन्ड ब्रेक होता है तो बेसिकली यहाँ से इलेक्ट्रॉन मूव कर जाता है इस प्लेस पे, एंड हेंस नॉट दिस बॉन्ड, एनी ऑफ दिस जर्मेनियम बॉन्ड विल ब्रेक अप. सो जर्मेनियम बॉन्ड से जो इलेक्ट्रॉन लिबरेट हुआ वो चला जाएगा इधर, एंड हैंस यहाँ पर क्या रह जाएगी, वैकेंसी, दैट इज अ होल. सो इट मीन्स एज देयर इज अ मूवमेंट ऑफ पॉजिटिव चार्ज, तो पॉजिटिव चार्ज की मूवमेंट की वजह से हम इसे बोलते हैं पी टाइप, यानी पॉजिटिव. पी स्टैंड फॉर पॉजिटिव. सो दिस टाइप इज or acceptor type. Now if we will draw its energy band diagram for this p-type semiconductor, again here will be valence band where you can show here electrons are present. This is conduction band, and there is one level. This level is known as acceptor level. That means in this acceptor level, the electron will gain sufficient energy, that is for germanium it is 0.01 electron volt, and it will be available for conduction. Further from the other germanium bond will be break up, and there will be leading to movement of electrons. And further electron from here will gain energy that is greater than band gap energy and move to conduction band. So in this way, in p-type semiconductor, conduction of electrons will be possible. Here we can see that number of holes are taken as the majority charge carriers. Here number of holes is greater. You can see here that अगर हमने एक एटम ऐड किया है तो correspondingly वन एक्स्ट्रा इलेक्ट्रॉन है, वन एक्स्ट्रा होल है यहाँ वैकेंसी है क्योंकि इसको फिल करना पड़ेगा. ऐसे ही अगर हम पूरी क्रिस्टल स्ट्रक्चर में 1% भी ऐड करें तो बहुत सारे होल्स होंगे और थोड़ी एनर्जी गेन करके वो होल्स की जगह पे इलेक्ट्रॉन आ जाएगा, जिससे कि वो होल्स की मूवमेंट होती रहेगी. सो हेयर मेजॉरिटी चार्ज कैरियर्स विल बी होल्स एंड माइनॉरिटी चार्ज कैरियर्स विल बी electrons. So this is all about energy band diagram of extrinsic semiconductors, that is n-type and p-type semiconductors, and corresponding to it you have to learn the differences between n-type and p-type semiconductor. So now just revise the basic concept of energy band diagram, intrinsic and extrinsic semiconductor. Now differences between extrinsic and semiconductor, do by yourself, as well as differences between n-type and p-type semiconductor. That difference point can also be asked. So revise the concepts thoroughly. Thank you. Have a nice day.